Electrical Design and Integration PCB for the Agile Ground Robot by Cadet Andres Rodriguez, class of 2022, from the 7th of January 2020 to the 17th of April 2020. Advisors are Dr. Daniel Gonzalez and Major Mark Lezak. The design challenge for the integration PCB for the Agile Ground Robot was to design and fabricate a printed circuit board to integrate all electrical components for the Agile Ground Robot to meet reliability and durability requirements. The Agile Ground Robot, otherwise known as the AGRO, is a robotics research center project that incorporates several different electrical components to make a robotic system for unmanned surveillance and reconnaissance missions. The system requirements for this PCB that will be used on the AGRO is for connection to all components on the AGRO. Now this includes the mbed microcontroller, the 3 different O-drive motor controllers can be controlled with CAN bus that needs a CAN bus level converter, and IMU that is going to use RS-232, which needs an RS-232 to TTL converter, 4 high-tech servo motors that incorporate a serial to TTL converter, 1 PPM radio module, a SparkFun SD card reader, and an NVIDIA Jetson Linux computer. Now, the PCB also has to include room for extra pins, in specific 16 extra pin headers with broken out reset buttons and various power and ground rails. Now, the initial design solution did not include VIN protocol converters, nor was it even a fabricated board. It was simply a proto board that had soldered on pins with few expansion capabilities, and as you can see, the photo is under initial prototype. Now, the main product is actually the PCB shield that will be fitted on top of the mbed microcontroller board that runs the Agile Ground Robot. And the printed circuit board incorporates the 3 different communication protocol converters while also incorporating the several different pinouts for expansion capabilities. And each of these different systems is labeled and color-coded below. Now, the capabilities of the actual PCB are including 2 dedicated and 5 selectable UART serial connections, 8 selectable S-bus connections for the servo motors, 8 dedicated and 8 selectable PWM connections, selectable CAN bus connectors, selectable S232 connectors via the DB9 connector, and connection to NVIDIA Jetson microcontroller, 5 volt and 3.3 volt power rails, and reset buttons for the mbed and Jetson microcontrollers. Now, the actual PCB only costs $50 to manufacture and assemble. The components themselves cost $18 to purchase, and the total cost is going to be $68. For future work, the PCB will eventually be implemented on the Agile Ground Robot Mark II for further use as a mission-capable robot. Along with implementation on the robot, the Robotics Research Center is going to be using this circuit board for other applications involving several different microcontrollers using various robotic components. Thank you for your time in viewing my poster for my independent study project.